Okay, Assalamualaikum and a very good day. So we meet again. So this is lesson 4, square wave inverter. So as you may recall, so we are concentrating only for a full bridge inverter here. So this is, I draw for you the full bridge inverter. Okay, make sure that you know or you practice on how to sketch this one. So this one is your S1, S2, S3, and S4, and this is your polarity. V out, the load is your resistor, and this is your VDC. So actually, the square wave inverter is the simplest square wave. The simplest square wave. This is the simplest inverter, okay, compared to the others inverter. So actually, so without further ado, we go directly on how this switch is controlled in the square wave inverter. So actually, very simple. So what you need, the signal that you need to be fed for this inverter is just a square wave signal. So you need to S1 and S2 must be given the same switch. So this is your switch. You must turn on it for the half period, and for the other period, and for S3 and S4 will turn on. Okay, so this is actually should be the same portion. Okay, so this is the signal that you must given for your switch. S1 and S2 must be given the same signal, and also S3 and also S4. So if S1 and S2 is turned on, okay, S1 and S2 is turned on, you will see that the KV, the current will flow from this one to the load and go back to the source. So the KVL is actually, you can see negative VDC, and then we assume that the voltage drop across the switch is 0. So negative VDC just plus V out must be equal to 0, and we will have V out is equal to positive VDC. So when we sketch the output of the V out, so for the half period, we will have a positive VDC. Okay, and what about the other? When S3 and S4 is turned on, so what happened? Okay, so it will flow here, go to S3 and go back to the S4. Okay, so the KVL during switch off is you will have a positive first, positive VDC, and then plus also positive V out equal to 0. So finally you will have that your V out is negative VDC. So for the another half period, the output voltage will be negative VDC. Okay, so you now have already converted a DC voltage into a AC voltage. Okay, but this is not a pure AC voltage, because usually when we want to connect to the load, we need to make sure that this output voltage should be actually a pure sinusoidal. Okay, so how to actually obtain this? Actually, from this waveform, AC square wave, we can actually obtain this sinusoidal by using what we call low pass filter. Okay, so this is actually a lesson for the square wave inverter. So next we will go for the what we call low pass filter and what we call harmonics in the next lesson. Thank you very much for your attention.